Sir, you are muted, sir.
Sir, you're not audible, sir.
Yeah, now audible? Yeah, it's
Now you're
okay.
audible.
So sometimes it is a 6 bit, sometimes it is a 3 bit, sometimes it will be a 4 bit. Because changing of the addressing mode, opcode value may be changes because the total number of addressing bits, if it is a 32 bit or if it is a 11 bit, it is almost will be same. Okay, so based on the addressing mode, or you can say particularly the number of addresses, that means a 3 address instruction or 2 address instruction, we found that the numbers of the operative bits required for opcode encoding changes. It is happening. And already, as I told earlier, that most of the time we found that um, most of the time we found that in whenever any CIR instruction is loaded from the CIR, the opcode part starts encoding. Of course, first starts encoding, particularly that the meaning of the opcode will be encoded. Most famous and easily called encoding techniques is decoder based. That what I have given here. So maybe inform in CIR current instruction registers. You know some part is opcode. Okay, it goes to the instruction decoding phase. Can you remember that portion? Instruction execution phase. We know
Yes.
that comes to the instruction decoding phase. So that number of bits actually it is fed to the instruction decoder. So this is the actual circuit based on some combination. If it's 0, then it will be activated. If it's 00, maybe 1, it will be activated, or if it is triple 1, it will be activated. So number of bit size automatically decoder. So it is n2 2 to the power n decoder. So if it is 4 bit, so according to it will be up to 15, up to 1502, like in this way. But maybe 000 it is a load operation. Maybe 001 it is a add operation. Maybe 007 it is a halt instruction. It happens. Am I clear? So to each 2k instruction, a unique binary pattern of length k is assigned. That is the our bit. Now in k2 2k decoder can be used to decode all the instruction based on the according to any one of the instruction will be activated, or the information of the signal will be activated. Again, I have already mentioned that the code whatever generated it directly go to the control unit. See this from decoder phase, and control unit actually takes the rest of the tasks to process the execution of micro instruction, because a single instruction can be executed successfully with the help of more than 1 or 2 or 3 micro instruction. That can happen. Okay, so that is the one portion. Now in expanding opcode techniques, that is that opcode sometimes suppose consider a 4 plus 12-bit instruction format with a 4-bit opcode and 3 4-bit address. So it is also 4-bit, it is also 4-bit, it is also 4-bit, and this is a 4-bit. Actually, total is 16-bit instruction format. Sometimes same opcodes are there. Now address become 2 field. So now this also allocated for the opcode, and this is the fix, because now opcodes come to the zone. It can almost 16 3 address instruction in this cases, because 4-bit 2 to the power 4, how many instruction possible? 16. So at most encode 16 3 instruction. If there are only 15 such 3 address instruction, then one of these unused opcode can be used to expand 2 address instruction also. Is it clear this point?
Sir, could you explain it again, sir? Didn't get it, sir.
Okay, I am telling you that okay, sometimes you found that you have a, if there are only 15 such 3 address instruction, 15, because total we know how many, 16. So you are telling that, okay, suppose I have 0002 4 2 1, that is 15, that is 14. So 0 to 14, total 15 instruction I have used. Okay, and rest of the one, that is we can say 15, I kept preserved. So that I have fixed here. And then because 2 address format we are using now, so this can be used as a opcode. So you can support 3 address plus 2 address also. In this way, again, if you would like to go for 3 address, 2 address, 1 address, that time number of 3 address should be at least, maybe maximum level is 14. So 0, 1, 1, 1, 0, it is for 2 address, and 1, 1, 1 you can keep for 1 address. Are you getting my point? So here also I fixed this, all this. Now you go for the opcode and this is 1 address format. Now all these things we are keeping, and now go for the opcode. I am telling that maximum total is 16 for 4 bit. If you do 15 3 address, 1 bit you can unutilized, and that can fix for the identification that it is not 3 address. It will go for the further decomposition. Now you are going for 2 address. Again in 2 address also 16 possible, but you are using 15 and 1 kept unused, that I have kept here. Then you go for the opcode. Then you again you can go for 1 address. Same thing here also, you can go 15 and there is a maximum possibility here. Then you go for the that means 0 address format. So what will be the possible number of instruction for 0 address in these cases? What will be the total maximum address possible if I have this format of the addressing format? Number of total 0 address, 2 address, 3 address. Can you tell me total address space required for this instruction format? So 15, 15, 2 to the power 4, 2 to the power 4, 2 to the power 4. Am I correct or wrong?
Yes, sir.
Yes.
Yes, sir.
Again, this 15 already there in 3 address. Now what, again 15 you will go for 2 address
But what trigger
plus
for only
again 15
15,
you will got. Yes.
15 into to the power 4 sir, only.
This already for 3 address. Okay. Now we are going this plus 2 address, because already one is fixed for what you call 1 all bit. Okay. Now again maximum 15 address, this for this opcode I can get for this opcode 2 address, like in this way. For again 15 I will get for 1 address, including these two. Again 15 to 15 with 0 address, 2 to the power 0. So like in this way, you can create total this amount of address space or total number of instructions we can store in the memory. So this is the advantage of encoding opcode. Now if we don't have such type of capability, suppose we don't have such type of capability, what will happen? Which one is good for me, us? In earlier cases, suppose in 4-bit decoder you are using, what you are using? 4-bit decoder. Then what will be total capability? Only 16 instructions. Am I correct or wrong? Only 16 instruction you can generate. But here the number of instruction is very high due to the opcode expansions. Is it clear? So it is found that this technology is very good for encompasses for opcode encoding part. But the problem is that in this opcode encoding, the number of bit to be searched for encoding, little bit the control unit design becomes very complicated. Note that the 3 address fields may not be necessarily be used to encode a 3 address operand. They can be used as a single 12-bit 1 address operand also. It is can be used. Can have some part of the opcode to specify the instruction format and length. If there are few 2 address instruction, we may attempt to make them shorter, instead to use first 2 bits indicate instruction length and 10 means to instruction elements 3. So like in this way, multiple instruction format length of the instruction can be modified by using instruction opcode. Now the famous problem is that regarding that Huffman encoding, how that the variable length of the instruction will be formatted. That is the one tag given the probability of the occurrence of each instruction. Before coming to this graph, this graph can be modified in 2 ways. So better we go for how to opcode encoding can be done. That means I told that in earlier cases in fixed length format, for particular some format, particular some instruction, if you have a 000, for that one instruction 0001, a specific instruction will be executed. So you know some specific length, but in the expanding opcode format, the length will differ. So that is the one problem, that the length of the opcode is now differ. Am I clear this point? Since the length of the opcode becomes, so there is a chance of getting variable length opcode. So variable length opcode, there is a possibility. So now how we can generate the variable length opcode? Fixed length is very easy using decoder. So Huffman is first proposed that variable length encoding format. Now let's see with example. First I go, then I will come. First it is mentioned for a particular computer instruction, that is you are going to generate or going to design a computer which have a multiple instruction format, and you found that in the most of the cases all the instruction may not have the same frequency. That means multiple in our hand, multiple instruction format. Number two, variable length. Variable length, multiple instruction, variable length. And number three is you can say also flexibility. Flexibility also becomes very high, but I don't know whether these are optimal or not. The solution is optimal or not, I don't have any idea. That I have to cross check the solution leading optimal or not, or you can say the best solution, efficient solution or not. For that purpose we have to go uh, to study that length format is optimal. We will go for study Huffman encoding first, and first we will encode each of the instruction, then accordingly we will perform the efficiency or calculation to estimate it. Now suppose you have a instruction. Okay, you have a instruction that maybe you can say load, add, mult, load, add, mult. So these are the instruction actually you are using. Just 1 minute. So it is found that load, add, multiple, or maybe division. These are the different. You will find cases that in a for particularly, suppose you are doing some particular instruction set. Now you are a designer. Now this is the part of a designer, and you have designed a processors or maybe architecture for which this instruction will required. Now you may found that most of the time all these instructions use of or the frequency of the times, the number of instruction will not be same for any type of programming applications found. Maybe load is frequently used in case of load store architecture, register based architecture, addition also, division also, but halt once used, maybe jump less frequently used. So these are the some instructions are present less frequency. The number of use of instruction may not be same. So initialize all the leaf node each with probability of the instruction. So first of all, I have to go the probability chart. That means suppose, extremely sorry, I have to open the latest PDF. Just 1 minute. Is it visible now? Okay. Extremely sorry for this. Am I asking this is a visible some instruction set? Load,
Yes.
store.
Yes,
Okay.
sir.
Yes, sir.
Yes.
Yeah,
Yes,
yeah.
sir.
So now you see that some instructions I have name given load, store, add, end, not, archive, jump, halt, and each of them some separate. That means you can say the frequency. So most frequently used I have written like with their probability, and less frequently I have written like in this way. Okay. So suppose you are designing a architecture who encompassing only this instruction format. This is the you are trying to design. So okay, I have mentioned these all. Now in this instruction format, you will find that the all the instruction does not have the same frequency. Okay, so we have a different frequency, and let's we will solve each of them individually. First, initially make all these according to the ascending order. So okay, in the chart I have given, see I have mentioned load, store, all these things are given. So you can make ascending order also. That means this one, this one, yes, this one, then this one, then this one, then this one. Like in this way, you can do ascending order. Can I make it or not? This is the one issue. You can do it. So according to initialization, the instruction from the memory side, which one is frequently used? 16 times if you execute an instruction, that there is a chance 1, and 4 times there is a chance to 1. Which is frequently used, this one or this one?
So the load.
Last one. So it is ascending order or descending order I have arranged?
Load.
Last one, load is less frequently or highest frequency?
So highest frequency.
High frequency, sir.
Okay, so I told that I have to start with the lowest frequency, LSB, which is our lowest frequency. Okay, so now if you go the lowest frequency, you will find that these two are lowest. So first add these two. Okay, then what will be the value? This will be the value 1/8. Okay,
Yeah.
so you will get 1/8. So I am getting here 1/8. Okay, so these are selection for the next level. So 1/8, after again rearrange, 1/8 will come somewhere any of this location. So it is become 1/4, 1/4, 1/8, 1/8, 1/8, like this is happening. Okay, so just forget this of initial level. I have considered these two. It go for the next level. Now in this level, again the next these are the two are the less frequencies available. Okay, like in this way, I have drawn this part. See, initially these two I have considered, and this has arrived. Then I will consider these two, then this will be arrived. Be careful that every time the no after doing a creation of this, I am forming a tree. So this node goes to the next level. Now in the leaf node level, you have to again combine to get the highest level subtree. So before that you can't combine. You first to combine these two, then again 1/8 will happen. Okay. Now next these two you combine, then it will be how much? 1/4. You combine this 1/2. Is it clear this level? Is it clear or not clear? Tell me. Okay.
Sir, can we
Yes.
not combine the 1/8 and 1/16, sir?
Which one? 1 by
Sir, we combine two sets. Sir, we combine two sets of 1/16s to form two 1/8s, right? So can't we
these
combine
two.
those two 1/8s to form 1/4?
No, I am telling that first you make it ascending order. I think this is the ascending order. Clear? After doing the
Yes.
ascending order, you first combine the least two one. It may be 1/6 or 1/8, whatever may be. The least two also I found these, so I have added. So this goes for next level. Now what are the rest part? I think rest part is this one again. Since this is the order I am following, then you go for the next two part. The next two part is selected, so you go next level. And then what of the rest part is there? These twos are left. Like in this way, I have finished this level. All the leaf nodes are traversed for the next level. Is this point is clear?
Okay, sir.
Yes.
Now again sort it. Again you sort it, then you will find that again this will come like in this way. So again I am making this one. So it will automatically come how much? 1 by 4. Is it clear?
Yes.
Now this 1 by 4 and this 1 by 4 will be 1 by 2. Clear? And this 1 by 4, this 1 by 2 will be clear 1. Until we are not reaching 1, we have to process. I think in a blank space we will try to understand it, otherwise it won't be understood. Okay. So first was 1 by, we are studying for blank page. So I think like in this way, it is like so now you just combine, you are getting 1 by 8. Once you won't get 1 by 8, it will be placed here. So you are getting 1 by 4, 1 by 4, 1 by 8. Actually, this is a new node created, na? So I am giving some star to understand it clearly. Maybe 1 by 8, like in this. So if you make this way, the chart, then 1 by 8 generated, it will be there. So now automatically next to next to is these two. Then this will again come here. Then these two will be the next two generated. So like in this way, whenever it will arrive in the next level, it will generate it. So generally people, what we do that, we prefer to go first 1 by 16 and 1 by 16. Just give 1 by 8. Okay. And you have a also, there is a 1 by 8, sorry, 1 by 16, 1 by 16, 1 by 8, 1 by 8, 1 by 4, 1 by 4. It was there like in this say, initially these two I have combined, so it is passed there. Clear? Now
Yes.
next is 1 by 16 and that's also 1 by 16. So either you can combine these two, this, then create the next one. I think better you first combine these two. That's why I have told that every time selected a new node with the value is created, after this node are excluded from the subsequent process for crossing them out. That's why I mentioned you just crossing them out. This part is clear. Now after this, that means node excluded from the subsequent process, what I mentioned, like jump and halt in the previous instruction are excluded from this shown. So two instruction node are selected and 1 by 8 is created. This was the I have created. In the next level, the new node with a after this exclusion, again you will go for the nodes corresponding to the other mnemonic, not, right shift, R shift, jump could have been chosen when there is a several possibility. See, you have a possibility that either 1 by 8 should be combined with this one, or 1 by 16 or 6. That means here multiple 1 by 16 was there. So question maybe arises whether I will connect this one or I will connect this one. Possibilities several, arbitrarily you choose. For better fitment, I have chosen this one. If this point is clear, multiple possibilities there, that time you can choose for the better possibility. I'm telling that someone can choose, there's a multiple possibility, 1 by 4, 1 by 4. Can I choose 1 by 6 to this ascending order? I have ordered ascending order. So minimum 2 will be automatically added because these are also two minimum, these are also two minimum. Anything you can start it. I have started from the leftmost for better readability. Then this also you can do. Then you'll get the 1 by 8. These will give 1 by 4 and this will give 1 by 2. Okay, that's up to there. Now 1 by 8, 1 by 8, you will get the 1 by 4. The next level. Now 1 by 4 will be combined with the 1 by 4, you will get the half, then half will combine the half, you will get the 1. So this is my target. Is it clear? This point?
Yes, sir.
Okay. After finishing this one, if you go this approach, this is we are adding bottom up. What approach? In bottom up. In bottom up approach, you must do one thing, that left right 0, right child node link will be 1, left side 0, right 1, left side 0, right 1. So it is 0, it is 1, it is 0, it is 1, it is 0, it is 1, it is 0, it is 1. This part is clear? Is it clear this point?
Sir, left. Acha, we are seeing from the top only. Okay. So in
I
that
am
case,
giving, I am going bottom up, from top bottom to top. So bottom up approach I am using. From bottom to up, from bottom to up we are following. That time left will be 0, this will be 1. Another approach we can follow in these cases. When you follow like in this way, 1 by 8, that is 1 by 4, that is 1 by 8, 1 by 4, that is half, that is another node. Okay. So that 1 by 8, 1 by 2 will be 1 by 4, then 1 by 4 is really 1 by half, and this 1 by half equal to 1. So this is top down approach. Clear? In top down approach, this 1, this 0. That means if you see actually reverse way, always you are doing right child 1, left child 0. Am I correct or wrong? If you see in this direction, if you see in this direction, it is become left or right?
So 0 for right and 1 for left.
Left. Actually, otherwise these two will not sync. Am I correct?
yes, sir.
Yes, sir.
Here 0 for left, 1 for right. In these cases, you will find 1 for left, 0 for right. Actually, but if you see, if you stand here, it will be left, it will be right. Am I correct or wrong? So both the way you can make. Ultimately, you will get this combination. Now, suppose this was our jump instruction. So what is the encoding jump for? Jump value is, see, from root you traverse 0, from the root you start traverse 0, 0, 0, 0. So mnemonic opcode for jump is 40. Clear? What is the value for maybe this for load instruction? For load we found that 1, only 1. Am I clear or not clear?
No,
Yes,
sir.
sir.
I don't understand the load part, sir.
Yes,
From
sir,
this the
load part
road,
it on.
it is the road. From the road to access, this is the, sorry, it is the load instruction. Sorry, this is the load instruction, not this one. It's the combination of these. You have to go 1, then also 1. That means 1, 1. Now it is clear. From the road, you first go
Yes, sir.
this
Yes, sir.
level 1, and then you go
Yes.
up to lift level. You have to reach. Now after maybe suppose this part. This part means because leaf root, all the leaf root contains the frequency of the instruction, and from the root you try traversing and
Sir,
go to the leaf node.
sir,
Here,
sir, is that the jump opcode and the load code just for the one node?
just for the
Just for the node which has one labeled, sir. Is that the jump and load code only for that label?
no, all are present in the same level. My question is that to reach the load or jump instruction, you traverse from the root and go to the leaf node. Then you will get the sequences of the edges marked with the level. So I found here 0, 0, 0, 0. Am I correct? This point is clear.
Yes, yes, sir,
Now
yes.
for this one, 1 and 1. So you are getting 1, 1.
Okay, okay, sir. So two
Now,
extreme nodes, two extreme leaf nodes.
no, you can go for this one. Maybe suppose this is the AND gate operation. Now code for AND. Let's try. Code for AND is what? 0, 0, then 1, 0, 0, 0, 1, 0. This for AND operations. I showed it different. This is a two extreme way you are getting. Maybe you
Okay.
go for this one. This one will be how much? 0, 0, 0, 1. Am I correct or wrong? Halt operation like in this way. So finally, what you will found? We will found that each of the instruction had separate value. Suppose I found the load instruction from the tree, code is 1, 1. We received it. Maybe store instruction, it is 1, 0. Am I correct or wrong? Maybe halt instruction, which have a frequency, that is maybe 40. So like in this way, you are getting some variable frequency. Sorry, variable opcode length. Am I correct or wrong?
Yes, sir.
So no fixed format which I have followed here. So variable format you are getting. The problem is that, as we know earlier, in the case of variable opcode or opcode whatever, the average number of bits needed per instruction can be calculated using this formula. That means from I equal to 1 to number of instruction, that's the mention, li fi. Li is the opcode length and fi is the relative frequency. So if I apply these things in case of what we say fixed format, that means fixed length format, that is decoder based. In decoder based, we found that suppose all are 3-bit instruction. Am I correct or wrong? All are 3-bit instruction. So you will calculate, that is for the calculate that number of average number of bits. Average number of bits needed per instruction. How in fixed length
Excuse me,
format?
sir.
Yes.
So how do you take all the bits to be three, supposing for the halt as we saw that there were like four zeros.
No, no.
So in
I
that
am.
case,
Yeah. I am going fixed length, not Huffman based coding. Huffman based coding just I
oh,
have
okay,
shown. I'll go there. I am going now fixed length. Huffman is the variable length.
okay, sir.
Okay. I have mentioned fixed length. That be decoder based. You just cannot remember decoder based. N2 to the power n. Is it
Yes, sir.
clear? Okay.
Yes, sir. Yes, sir. Yes, sir.
In decoder based, it is 3 for all. So 3 into 1 by 4 plus 3 into 1 by 4 frequency you add plus 3 into 1 by 8 plus 3 into 1 by 8 plus 3 into 1 by 16 plus 3 into, like in this way. You get my point? All the frequency, the number of frequency of the instruction which I have done here, you know this frequency. You know this frequency, all this frequency. That means for 3 into this into 3 into 3 low, you will get some summation. Getting my point or not? You will get it is coming finally 3 bits, average number of bits, and it's happening because it's a fixed length format. All are using 3 bits. So by default, even I am using the formula li fi. Fi is the number of frequency and the total number length. Average will be automatically the fixed length format is always fixed. Is it correct or wrong?
Sir, so
Yes.
Li is like the input lines in the decoder.
Li is the length of the bit required for the opcode.
Okay.
Opcode length. Opcode length. In decoder based or fixed format, it is 3. I have considered, for example, in these cases.
Okay. Okay. Okay, sir. Okay, sir.
Okay. And the frequency will be again frequency 1 by 4, 1 by a 16, 1 by 8, whatever you consider so far. So you found that fixed length format is become 3. But now our condition is that we are not using fixed length format. Okay, we are no fixed length format we are using. So in these cases, in Huffman, what is the advantage we'll get? Let's see. Okay, so now again in the Huffman encoding, you apply this formula. You apply the formula means that anyhow you first, what is the length for the load? Load length is I think 2 bit because 1 1. What is the length of the load? 2 bit.
Yes,
For
sir.
the load instruction, it is 2 bit. Am I clear? So it will be 2
Yes.
into 1 by 4. In earlier case, it was 3. Plus, I found the 2 is the length for may other also. 2 into 1 by 4. Like in this way, add. What is the length of the your halt? I think 4 bit, triple 4 4 into 1 by 16. Am I clear this point? 4 into 1 by 16, 4 is the length of the frequency. If you see here, if you see what is the length of the halt here, all 0, 1 2
Four.
3
Four,
4. What is the number bit? 4 bit.
four.
Here it is 2 bit. Here is the 2 bit length. Am I correct? That's why if you apply LI for suppose this 3, you will find 2 into load frequency is 1 by 4 plus store 2 into again 1 by 4 plus dot dot, you will find here halt, that is number of 4 and its frequency is 1 by 16. Am I clear?
Yes, sir.
You have to solve all this problem in the exam. So is it clear or not? Today I will give mathematics immediately. Who will solve immediately, he will be rewarded. I will point his name in my copy. So classes performance very important. In online now it is started classes performance also. You told that online is a headache. Now classes performance is the more headache. So be careful. Immediately after this class, I will give you 10 minutes and an example will be given. So this part is clear. Finally, you will get the value is 2.75 after calculation. Adding, you will find balance coming 2.75. Is it clear this point?
So can you explain once more the last part?
Last part I am telling, the length of the bit, you will make the chart, load, store, add, not, everything from the graph, you will make the chart. From your graph, you will make the chart for each of the instruction you will get from the, if you traverse it, automatically length will go maybe 0, 1, 1, it's a 3-bit length, 0, 0, 1, 1, 4-bit length. So according to the different frequency, different length of the opcode will be generated. Multiply the opcode with their frequency, you will get the LIFI. This part is clear or not clear? You will
Okay,
finally get LIFI, and I apply this summation of LIFI, so you will get 2.75. It is for Huffman. Shankit, that is clear now? It is for Huffman variable code format.
Yes, sir. So it means that when we use Huffman instead of the normal fixed decoding, we save almost 25% of the storage space.
Very good. Let's see, the game starts again. Okay, so up to this is clear. But what our information theory, our information coding theory, that is the, we can say, information coding theory. Most of the thing in the computer science, you know, one person you remember, whenever any communication term is coming, bit information is coming to saving the bit or something, we found that up to that, whatever discussed, it is found that 25% saving. Very good. But found that information coding theory, and you will find one person named Shannon in everywhere. Shannon. I think without Shannon, the world will not be so much comfortable for all of us. So Shannon has always given lot of theory in entropy, lot of theory in coding theory also. So okay, now information coding theory may be proposed by some scientists. The optimum number of bits needed. You remember, here now we are getting optimum. I don't know fixed is optimum or this one optimum. The optimum number of theory is needed. Just 1 minute. Horrible student. Now is it clear? Optimum number. It is the again formula, negative value of summation of I1 to N2 number of total instruction divided by f of I frequency log base 2 frequencies fi. They are telling like in this way, then you will get the optimum number of length. Then what will be the redundancy for each bit? Redundancy will be actual length minus optimum length. Optimum length divided by actual length. You have to find the redundancy for Huffman algorithm. You have to find the redundancy for fixed algorithm also. You have to find both redundancy you find, and then you can compare whether you are going right path or not. So now if we apply this formula for particularly in you can say Huffman encoding, that means I can apply minus 2 frequencies 1 by 4 log 2 1 by 4, 2 number instruction having 1 by 4 plus again 2 the length 1 by 8. Is it clear? Log 2 1 by 8. Huge proofs are there. I am not going for this proof, just I am trying to solve it. Plus 4 into 1 by 16. 4 signals are there having 1 by 6 probability. 2 instruction there having 1 by 4 and 2 instruction having 1 by 8. Again log 2 1 by 16. The value will come minus 1 minus 0.75 minus 1, you will find 2.75. That is for Huffman. Sorry, this for fixed length format. Okay. So in fixed length format, it is found that 2. Sorry, this is I found for Huffman encoding because based on the frequency, because this should be the our optimal length should come for any bit. That means the instruction whatever we have generated. Now if we apply in Huffman 2.75 was actual estimated, and what should be optimal? 2.75 divided by 2.75, which almost what? How much redundancy?
Zero.
0.
0. Very good. So my
Sir,
students are, yes.
sir, but the optimal length, sir, the optimal length is 2.75. How is the
Yes.
actual length also 2.75? I didn't get that part. Or how did you
Okay.
calculate the optimal length for that matter?
Optimal is the formula. That is the formula I have mentioned. Minus
Okay,
I1
that
to
is the
n.
optimal length formula. Okay, sir. Okay, sir, got it.
This formula information coding theory proposed. For any instructions or architecture design, you have to follow this formula. Okay, this is the very important formula. You have to follow it. Am I correct? This formula for information coding theory, you just ICT you can mention. Okay, very famous subject. They are told that if such for any number of instruction when you are trying to design it with the such frequency, this is the formula you have to follow. Okay, the number of length for each of the length is the total number of length for. So I found that in my previous cases, suppose let's see in number of frequency, the main table, if you go for the main table, you found that this is the, so how many, this is 1 by 4, so two instruction having 1 by 4 frequency log to 1 by 4. Am I correct? Again I have to design now, then what will they, this also 2, so 2 into 1 by 8 log to 1 by 8. Clear? So like in this way, 4 instruction you have found. So 4 into 1 by 16 log to 1 by 16, and their value is coming 2.75. So they are suggesting, they don't know you are applying fixed length format or you are using Huffman or not. Whatever maybe you have created new method also, we don't know, but they are suggesting that optimal length should be, this optimal length should be 2.75. Clear? Now redundancy, if I use our fixed length 3 is the actual, 2.7 the, so you will get this value. Am I correct or wrong?
Yes.
You will
Yes,
get
Naveen.
this is for decoder base, that's why I'm writing RD, and RH for Huffman you will get 2.75 minus 2.75 by 2.75, you get 0, and you'll get some value here, probably it will come 1 by 12, like in this some value you'll get. Okay, anyhow you will find the, sorry, you will find that redundancy is more here, 0 here, something you will get
0.25.
6.8.33%, you cross check it.
Sir,
Yes.
one more doubt, sir. We are getting 2.75 after we are trying to calculate the average number of bits, sir. So then how are we
Yes, in
getting?
case of half page, in case of Huffman.
Yes,
Yes,
sir. But
tell.
how are you getting the three, sir?
It is for fixed length format. It's a D. I have written RD. In fixed
Okay.
length format, 3 decoder size is 3. I have considered now 3 to
Oh, yeah.
n
Okay,
by
that
n.
example, sir. Okay, sir.
Memory short. No problem. My students are very serious this time and asking question. I am very happy. At least I am teaching some good students. So these are the 3 I have considered. Am I clear this point? I have considered 3. So, and in the decoder side, since it's 3, is it clear this point?
Yes, sir. Yes, sir.
Okay, because question will come very soon. So doubt clear session as much possible. So we found that finally the redundancy becomes 8.3% more in fixed length format. So which is very good for us. Finally, which is good for us.
And the Huffman one.
How the
Uh,
Hoffman's was less redundancy.
Uh, but very sorry to say, Huffman never used in our modern applications. Can you tell me why? In some computer, we found in earlier some computer, particularly the computer name, I can't recall the actual name, some computer B1700 computer, that means some model we can say Barracks, actually Barracks B1700 model use this Huffman coding. Even though they know the optimal length, they are using, maybe page will be safe. The problem is that, can you assure me, I know Huffman is good, redundancy is less, but still fixed length format is most used. Any idea why? As we know,
Sir,
Huffman
because
scheme
sir,
has,
because the Hoffman sir might vary and the fixed length, like you can like specify knowing that what are the like you only need the specifications in order to determine how much space, how much will be the bit length. So
no. That is not in our hand. It is hand managed by the computer hardware. Suppose sufficient memories are there. So in case of sufficient memories case, I think there will be no problem. We know Huffman scheme achieves an optimal result by keeping redundancy to a minimum value. That is point is clear from our side. But it is found that when opcodes are encoded using Huffman, actually actual problem like the decoding process takes more time, because you have to, for any opcode process, it is not a fixed date. In case of what happen, suppose you are using decoder. In decoder format, what happen? 000, directly this will be activated. Clear? But in Huffman format, to get the zero, maybe 000, you have to traverse this path. Maybe sometimes 00001. He has to traverse this part. That means searching time. Are you getting my point or not? Searching time from any instruction memory or somewhere else. So I can say the decoding, encoding using Huffman, the decoding process takes more time because a search must be conducted on the Huffman tree. Am I clear this point?
yes,
The
sir.
search time is the main bottleneck for the computer. Even I know this is most I can say most optimal Huffman, but Huffman never used, only for the speed. The speed in decoding process is very high because less searching time is required. Immediately for a particular one segment, it will be created. Am I clear this point to all of you?
Yes,
Yes,
sir.
sir.
Okay, now write a question, all of you. Okay, I am giving the question in the frequency of the, suppose some instruction I am writing I0, I1, I2, I3. Are you writing, all of you? I5, I6, I7. So frequency is 1 by 4, 1 by 8, 1 by, students, are you writing?
Yes, sir.
Yes, sir.
Yeah, must write it. Formula I will write, don't worry. I will give all the formula along with this question also. Okay. Average bit length summation of I1 to N Li, length of the code and frequency of the code. Optimal length is will be, optimal length for a particular bit will be minus Fi log to, sorry, summation of I1 to N log to Fi. So this is the formula. Now you compute it.
Sir, will we compute the redundancy?
You encode this instruction using Huffman method and calculate the redundancy introduced by the Huffman scheme. First of all, tell me, if I use this in a fixed length format, what will the number of bits?
Sir, sorry,
So
repeat the question, sir.
I have to
three.
calculate three. Yeah,
Three,
understood.
sir.
Sankit, I
Three
told that
bits.
fixed length format. If I use fixed length format, The number
three.
of bits required 3. You know why?
Sir,
Because
I0 to I7.
yeah, so
0
that
to
is
7, 8
3.
bits.
Now you apply rest of the part Huffman and tell me the redundancy. Do it now. Do it now. Independent Republic Day celebration Bunaja. Bonus mark for Republic Day celebration. Do it. The formula is clear to all of you. I have written. Again, I am telling you the optimal number of bits needed to encode a set message is that as I have written here. I equal to 1. Here one thing you just mentioned before frequency, the number. One number is the number of instruction appear. That's why I want to and I have written to understand it. Okay, that's why automatically n will come here. That means 2, 3, 4. In these cases, I think optimal length will be, if I consider the mathematics, optimal part I am solving. You do the Huffman part. Optimal bit length will be minus how many bits are there? Minus I think in the 1 is 1 by 4. 1 by 4 into log 2, 1 by 4 plus 1, 2, 3, 4, 5. 5 numbers of 1, 2, 3, 4, 5. 5 numbers of 1 by 8 instructions are there having log 2, 1 by 8 plus 2 number of 1 by 16 log 2 1 by 16. So this is the given. So minus, it will be around how much?
23 by
Minus
8.
total calculated.
Yes, sir.
2.875.
It is
23 by
2.875.
2.875.
23 by 8.
23 by 8.
Are you telling that?
2.87.
2.8 probably. Okay, no problem. So optimal you are getting. Now calculate. You are very faster than me. Okay. Now calculate the part 1, rest 1. Huffman's. Now Huffman you have to make the Huffman encoding. I am waiting for the response from your end.
Sir, are you asking about the redundancy?
Think about the redundancy. That
Sir,
to find out
sir, I'm just doing the addition part now, sir, of the Hoffman actual length.
redundancy. You have to make the graph first, otherwise you can't do it.
Yes, so the graph has been done, sir. I made the graph, sir.
Okay, very good. Make it, find out the redundancy.
Sir, that one also came 23 by 8 for me.
Yeah, it is coming
So this
23
is,
by 8. Miracle.
yes.
Then again, same problem will happen, na? Near about 7 or 8%, we can say block code scheme introduces redundancy more or less. In this case, it's more, I think.
Sir, in this example, could you just show, sir, how are we getting the actual length, sir? Because
Actual length in Hoffman,
Hoffman,
if
sir.
you, whatever value will come, you can that value by using your tree concept, LIFI concept, LIFI, you find the
Sir,
length.
I'm not getting the LI only, sir. That is where I'm getting stuck, sir. If you could just draw,
LIFI,
I
LIFI,
was
LIFI.
confused. Three part, sir.
Sir, it is coming 3.5.
See, okay, I'm coming. In Huffman tree, you have to use this same formula for Huffman tree also. Apply this formula also. For
It is
Huffman,
6.6%.
maybe, yeah, very good, very close to this. Everyone should be matched with this one.
0.75 is coming.
6.6 is like I've done it roughly, like I've not used calculator, but just rounded it up and it's coming 6.6.
Yeah, sure, no problem.
Okay. Thank you, sir.
So this is up to the lectures of Huffman encoding. I think my point, is it clear to all of you, Huffman encoding, or you have some doubts?
Sir, it would be, sir, I just could not understand the part where we are finding out the LIs, sir, like the individual LIs, sir. How are we doing that, sir? Like the number of ones and number of zeros, sir, that way, sir. If you could just
Okay.
show that part once more, sir.
Okay, that means in case of in Huffman or fixed line format.
Sir, Halfman, sir, Halfman.
Okay. Suppose one example is there, I am calculating from here. In the Huffman format, see the halt instruction 0, 0, 0, 0. So that's why it is a halt is length is 0 and L is value is 4. L value is 4, H is 4. L value for this one for add instruction, L value is 3. For this instruction, L value is 2. Am I correct this point? Rajata, is it clear to you?
Yes, sir, yes, sir, yes, sir.
Now you apply LIFI formula summation. So in this case here, it will be 4 into 1 by 16 plus for this also 4 into 1 by 16. I think 1, 2, 3, 4. 4 instruction you have found which have 1 by 6 na? Length. Am I
Yes,
correct
sir.
or wrong? So
Yes, sir.
4 into 1 by 16 plus 1 by 16 plus 1 by 16. I can write like in this way 4 into, if I take common 4, so these 4 are okay. Now these two are 3 bit. It means that plus 3 into 1 by 8 plus 1 by 8 plus 2 into 1 by 2 plus 1 by 2. Am I clear? So using this formula, you found out the Huffman's problem.
Okay, sir. Okay, sir.
Any doubts? Any other students?
Sir, it should be 2 into 1 by 4 plus 1 by 4, no, sir?
2 into, oh, sorry,
1.
yes. Frequency is 1 by 4. Yeah. It is correct. Yes, Orko. Your point is clear now?
Yes, sir.
Okay. No issue. Very good questions. Because sometimes typing mistakes also give illusion to all of your mind. So I think this part is clear. Encoding options. May I go for the next one? Okay. So at least you compute. I will give some assignment from this chapter. Maybe this is another assignment. In your assignment copy, today must prepare the question whatever I have given. It is assignment number 2. I think I have given assignment 1 also. Did you solve it last class? I have given one assignment.
Yes, sir.
Tell me what is the assignment?
Sir, it was we were supposed to find out the number of there were a set of instructions that
Yeah.
was for find out what was be the final result in the main memory.
Yeah, the proper justification. I
Yes,
have
sir.
written and shown in the exam, but you have to write the justification. So make a copy of assignment because if suddenly suppose the institute is open and physical class starts, suppose, and there is a chance also after May or April, I don't know. So that time I will ask this copy to submit. Otherwise, suppose the code process is continue, that whatever the situation continues. So what happened that you have to write in assignment copy and scan it and make the PDF and send it to me at the end of the semester maybe. But you should do it regularly, because one day you can finish all the assignment together and can submit. I can touch it. The handwriting, that light of format and text and scan quality automatically will help me to identify it is a one-day task or it is a regular task. Did you get my point? So that's why I'm telling daily day, at least after the end of the class, solve one by one question. Okay. So write one more questions. This is the
Sir,
assignment
this
number.
this question which you gave right now is this second question for the
Assignment.
assignment.
Yeah, assignment.
Sir, okay.
Or note down in assignment copy. Though I help you a little bit to solve, but I think correctly you will solve with some proper calculator. The actual data will comes out. Okay. Now the third question, assignment question third. I'm just writing. You write a question. Am I audible to you? Because the text you have to write. You write in a computer instruction format. In a computer instruction format, I think in the Wacom writing style, it will not be clear for you. Okay, instruction format. Did you write it? Just give me anyone. Okay. The instruction length and the size of the address field are instruction length, and the size of address field are these respectively. Okay. Now see, total number of instruction length is what? 11 bit. Am I clear? Address field I have given 4 bits. Address field 4 bit means the operand address. Address field for operand address as well as the opcode also specifies some. The question is that is it possible to have 5 to address instruction, 45 one address instruction, and 32 zero address instruction. Today, Shankita, Orko, Prajuta, Karam, all of you have answered simultaneously. So I have captured your response. Okay. So don't worry, the sir has not ignored the point. I ignore everything I have recorded. Don't worry, because my recording of this video will understand how he has performed at the right time. Okay, so is it possible to have 5 to address instruction, 45 one address instruction, 32 zero instruction using this format? Justify your answer. Okay.
Sir, is the opcode also 4 bits, sir? Opcode size?
Opcode not mentioned. Opcode not mentioned. I have given the address field. Rest of the part is opcode because here variable length opcode is used. No fixed
Okay.
length opcodes are used. Am I correct or wrong?
Okay, sir.
Okay. So this is the assignment number 3. Now you go for the assignment number 4. Assignment number 4 is that you just write same question. Okay. Same question as it is mentioned in assignment number 3. Determine whether or not is it possible to have 7 to address instruction, 15 one address instruction, 18 zero address instruction. Is it clear?
Yes, sir. Sir,
So
15
yes,
8 at
yes.
the 15 8 address or 0 address?
15 one address instruction. 1 or 18 is zero address instruction. Is it clear? Okay, I mentioned the 1. Now it is clear. 1 and this is zero address. Is it clear now?
Yes, sir.
Whether it is possible or not. All are continue, na? Now again continue of this question. Continue of the question, that is assignment number what? 5, na?
Yes, sir.
Yes, sir.
Assume that computer architect has already designed 6 to address. 6 to address and
Same specs as before, as 3 and 4, sir.
yeah, 3, 4, 5 all are same.
Okay, sir.
Because all are same means I am telling that length is 11 bit
And
and
4 bits.
4 bit for address of operand address.
Okay, sir.
4 bit for operand address. This is the only thing same for all this question. Okay.
Okay,
Now
sir.
assume that the architects already designed 6 to address and 24 zero address instruction. Okay. Clear? Using, now tell me the very important part, using the instruction format of assignment 4. Using assignment number 4, assignment number, that means whatever I have told, that means 11 bit is the length and 4 bit is the address bit. Clear? Assignment 4 or 3? Our question 3, na?
3.
Okay. Or 3 or whatever. All are using same format. Okay. Now, question is that what is the maximum number of one address instruction that can be added to the set? If they are using now 6 to address and 24 zero address, what will be the maximum number of zero address instruction possible?
So one address you said.
Sorry, one address, because 2 and 0 already mentioned, na? Okay. Number of, sorry, one address. Am I correct this point?
Yes, sir.
Now, with proper assignment number 6, assignment number 6 is that with proper figure, with proper figure, you find the difference. Figure an example also. Example on your own. Okay, example on your own. You can choose. Or right, I am giving one example here. It is 1000, like in this way, up to 9000 is the memory location, or are 1000 byte addressable. Okay, suppose this is the memory bank. Find the essential difference, not write many more, only the essential difference. Are you getting my point? Essential difference between base and index register addressing mode. Am I clear your question? Is the question clear to you?
Yes,
So
sir.
can you describe it once a little more? Will be better, I think. So can you please describe it a little more, like what to do exactly? I didn't understand.
I intended proper figure. That means use a register, a CPU address, which have some opcode and some address you go for search. The index will be there. Index will be added with the figure, then search to the memory. So what does mean the basic differences for base? I have given my reference material to the Moodle. Study those reference material. Then you find out the question. Find yourself. If you did not find, then I will help you to understand. Okay. Am I clear?
Sir, one thing, I got many of us got unenrolled. So can you upload this material in MS Teams as well temporarily?
Why unenroll?
Sir, I don't know, sir. We had enrolled, but automatically I think we got unenrolled.
No,
I checked.
Many of us are facing this problem.
you people
Yes, sir.
just
Automatically we got unenrolled.
no problem. Those students are unenrolled. they give me their roll number and name, I will roll it automatically there.
Okay,
Don't
sir.
worry. But module is the main thing through which I will analyze. MS Team I am just taking as a classroom, not more than this. Clear?
Okay,
So
sir.
can you upload the recording files in the Moodle too?
Yeah, I'm just editing because so many noise, so many interaction are there. In cutting all these things is a abstract option I will give to the Moodle. That looks time saving also for me. Okay, I will give very soon. Don't worry. Everything I am downloaded, I will day by day I will upload it. Okay, before the
So
your
also in the
examination.
Moodle it shows that the enrollment is disabled. Earlier I have enrolled in that,
I
but
told that
now
I
it is
told that those person already does not having access to the model. Please write your name and roll number in the WhatsApp. Automatically today, within the today, I will roll you and activate to the model. It is my responsibility. You should not feel any discomfort or maybe some problem from our end, any facilities. It is my
okay. Thank
responsibility.
you,
I will
sir.
do. You just raise your voice, I will solve it. Okay.